Hi everyone, welcome to Netgate Chemistry. So today also we are going to discuss one question which was being asked in the CSIR net exam, and the topic was electrochemistry. So the question given is, consider a cell. This is the cell given to us, right? And EMF of cell is given as 1.71 volt at 25 degree Celsius. We have to find out the equilibrium constant for the reaction. So if using this cell I want to write a complete cell reaction, then what I'm going to do is, what will be the cell reaction? Basically here Zn solid is changing to Zn2 positive, right? So Zn changing to Zn2 positive and Fe2 positive changing to Fe3 positive, right? But this is given in terms of, here it is anode and here it is cathode. So at anode oxidation takes place, okay? Here oxidation has happened and here we have to do the reduction of Fe. So this is the anodic compartment, so that is why we will write as the oxidation of zinc. So here zinc is getting oxidized, so Zn is changing to Zn plus 2, and this is the cathodic compartment, right? So here what will happen, here reduction will take place. So what we will do is Fe3 positive will get reduced to Fe2 positive. This is how we write the reaction. One is getting oxidized, right? This one is getting oxidized and this is getting reduced. So this way we have written this equation, right? So now we need to balance the equation. So here Zn is losing 2 electrons, so Fe will multiply this by 2 because here there is exchange of only 1 electron. So this will be the complete cell reaction, right? So from here we can also understand there is exchange of 2 electrons, so value of N will be 2 here, right? So this is so far about the cell reaction. Now we know one formula. EMF of cell is equals to E naught minus, because they have given the temperature 25 degrees Celsius, so we'll use 0.0591 upon N. N is 2 log of concentration of products raised to power their stoichiometric coefficient, that is Zn2 positive into Fe2 positive raised to the power 2, because the stoichiometric coefficient of Fe2 positive is 2, divided by concentration of reactant Fe3 positive raised to power the stoichiometric coefficient, that is 2. Now the concentrations of Zn2 positive, Fe2 positive and Fe3 positive are given in the question. So we will simply put those in this equation. So we will get E of cell is equals to E naught minus 0.0591 divided by 2 log of concentration of Zn2 positive is 0.01. From here Fe2 positive 0.001 square upon 0.01 square. Okay, so this cancels out with this, okay, and we have to divide these two. So E of cell will be equal to E naught minus 0.0591 divided by 2 log of, when you solve this you will get 10 raised to power minus 4. Now what else has been given to us that we have to find out? Now EMF of cell is given in the question as 1.71, so we'll put that value. 1.71 will be equal to E naught minus 0.0591 by 2. Now you know the property of log. Log of x to the power m can be written as m log x, right? That is, this power can come here, so that is what we are going to do. This minus 4 will come here, so what will happen, minus changes to plus. So now what happens, minus changes to plus and this 4 comes here and we get log of 10 here, right? Now 2, 2. 1.71 will be equal to E naught plus 2 multiply 0.0591, right? Now on solving, you are going to get the value of E naught equals to 1.5918. Okay, now we do not have to find out the E naught of cell, but we have to find out the equilibrium constant. So we have to find out basically the relation between equilibrium constant and E naught. So we know the relation, right? First we know the relation between delta G naught and equilibrium constant, which is delta G naught equals to minus RT ln K. Okay, so also we know that delta G naught is equals to minus NF E naught. So putting this value of delta G naught here, what we will get? Minus NF E naught equals to minus RT ln K equilibrium. Now minus value of N is 2 here, right? So 2 multiplied by Faraday's constant multiplied by 1.5918, that is E naught, equals to minus of R, that is 8.314 into temperature, that is 25 degrees Celsius. In Kelvin it will be 298 Kelvin into log of K equilibrium. Okay, now on solving, what you are going to get is, you want the value of this log of K equilibrium. You know the value of Faraday constant, that is 86500. So also there is one more thing, that is if you want to change this ln into log, so you have to also multiply this by 2.303. So you have to solve this whole equation, that is minus 2 into f into 1.5918 equals to minus of 8.314 into 298 into log of K equilibrium into 2.303. Why I have multiplied it by 2.303? Because I wanted to change this ln into log. So on solving this equation, you are going to get the value of log K equilibrium equals to 53.84. okay, negative will cancel out with negative, and K equilibrium will be equal to 10 raised to the power approximately 54, right? This log goes here, becomes 10 to the power, so you will get K equilibrium basically almost equal to 10 raised to the power 54, right? So you are going to take this K equilibrium onto the left side, and log will go to the right side, becoming 10 to the power. So approximate answer will be equilibrium constant equals to 10 to the power 54. So correct option is option B. So I hope this question is clear to you. Basically we have to find out the equilibrium constant, but we don't have any direct formula. So first we are going to find out the value of E naught, right? We know the standard formula. First we have written the equation, then the standard formula for EMF of cell. Using that formula we found the EMF of the cell. After that what we did was, we made an equation, not made, we know this equation, relation between delta G naught and the equilibrium constant, and also we know the relation between delta G naught and EMF of the cell. So we used these two relations. First is this one and second is this one. Using these two relations, we derived the relation between E naught and the equilibrium constant. Why? Because we knew the value of E naught. So using these two equations, we derived an equation which was giving the relation between E naught and equilibrium constant, because we had the value of E naught. So using this equation, we just substituted the values and also changed this ln value, right? This ln was changed to log by multiplying it by 2.303, and on solving we got the approximate value of equilibrium constant, that was equals to 10 raised to the power 54. So I hope this question is clear to all of you guys, right? So with this we'll solve some more question in next upcoming videos. So far from my side, that's it for this video, and thank you so much for watching.